Let's solve the inequality that results from having g of x greater than 4. Okay, so x, absolute value of x minus 7 is greater than 4. Okay, now we talked about less than being an and problem. Let's talk about now greater than. And I want you to think, when you hear the word greater than, the phrase greater than, I want you to think great or. Okay, this is an or type problem. Or. Okay, we'll talk about what that means in a second. But for now, let's work it out. X minus 7 greater than 4, or x minus 7, flip the sign, less than negative 4, right? Remember, when you change it to a negative, you have to flip the sign with it. Okay, so these are pretty easy to solve. Add 7 to both sides. 4 plus 7 is 11. Or add 7 to both sides. Negative 4 plus 7 is 3. So x is greater than 11, or x is less than 3. Okay, so now the word or. Why does that matter? Okay. Well, basically, instead of where we want them to overlap, right, with and, these do not have to overlap. Okay? Don't have to overlap. Okay, so what does that look like? 3 is here somewhere. 11 is here somewhere. Let's color code this one again. So 11. X is greater than 11. Now x cannot equal 11. X is greater than 11. So I'm going to put an open circle here. Let me try that again. That was a terrible open circle. Okay, and then I'm going to say everything to the right of 11 represents the numbers greater than 11. X is less than 3. So 3 and everything to the left of 3 represents everything less than 3. Okay, so now think about interval notation again. This is two segments that do not have to overlap to be included in the answer. Okay, so the first one is negative infinity to 3. The second one is 11 to infinity. And don't forget our union in between. Okay, so there we go. That would be our solution set. Now, notice I used parentheses and not brackets. Again, that's because these were not greater than or equal to. They were just greater than. Okay, and less than, not less than or equal to. Okay, so there we go.